In 2003, an American chemist formally discovered ocean acidification. In 2004, the first annual Ocean at High CO2 World Conference began. Our actions seem promising. The climate movement has just proceeded. But while our human intellect began to conquer the problems on land, humanity still lacked the answers to the climatic changes beneath the ocean.
Greetings, I'm Christopher Kwok. And I'm Nicholas Kwok. We're a sophomore for Sequoia High School and we invented Chaeto Biofilters, chemically modified Chaetomorpha to mitigate ocean acidification.
Before it's too late, the invention pioneers an ecological solution to ocean acidification through Chaeto Biofilters that implement a novel strain of algae in oceanic ecosystems.
Our inspiration stems from our trip to Australia in 2017. While there, we toured wildlife sanctuaries and snorkeled in the Great Barrier Reef. Despite the abundance of nature, we witnessed the devastating effects of climate change and its degrading impacts on the planet.
According to the National Oceanic and Atmospheric Administration, ocean acidification shifts the Earth's ocean toward pH-neutral conditions by absorbing the atmospheric carbon dioxide and increased concentration of hydrogen ions combined with carbonate to form bicarbonate ions. This concerns marine organisms that need carbonate to construct their calcium structures.
As humans exploit fossil fuels, ocean acidification has increased the water salinity by 26% since 1850, jeopardizing 25% of marine biodiversity. With unprecedented trends, the environmental consequences of ocean acidification are becoming more irreversible and tethered to larger social and economic impacts worldwide.
As the crisis festers, the fishing, aquaculture, and tourism industries are endangered, foreseeing a $100 billion loss by 2100 for the mollusk and fish market and a $5.4 billion plummet to the Australian economy for the tourism around the Great Barrier Reef. Today, ocean acidification remains an unsolved crisis. Solutions include long-term plans reducing carbon emissions or coral restoration, which are expensive and unscalable.
Hence, we present Chaeto Biofilters, floating devices that contain our modified algae. By utilizing keratin and phytic acid to chemically modify the enzymes in Chaetomorpha, we produce algae that mitigate ocean acidification by increasing pH, reversing the interconversion between carbon dioxide and water, and dissociating ions of carbonic acid. We selected the green macroalgae for its biological abundance, sustainable cultivation, and ability to non-impede coral growth. Designed for global applications, Chaeto Biofilters act as marine filters, requiring no electricity. Each 2,000-gallon biofilter can cycle 3.5 million gallons of salt water in 2 months.
The invention process consisted of 2 stages. Stage 1 was modifying the Chaetomorpha. To modify the algae, we tested 0, 2, 4, and 6 grams of keratin, phytic acid, and iron in separate aquariums. By measuring the hydrogen and bicarbonate concentrations, we discovered the optimal quantities to perform the enzyme modifications.
First, we increase the hydrogenase enzyme through keratin. This enzyme catalyzes the reversible oxidation of molecular hydrogen through the use of low potential electrons. We use keratin to transfigure the algae's pigmentation to absorb marine light more readily.
Second, we decrease the carbonic anhydrase enzyme through phytic acid and iron. This enzyme catalyzes the interconversion between carbon dioxide and water and the dissociated ions of carbonic acid. Since the enzyme is a metalloid as a zinc, phytic acid and iron can inhibit zinc intake.
Our investigation discovered that 6 grams of keratin and 4 grams of phytic acid performed the enzyme modifications. After 30 days, the novel strain algae increased the hydrogen gas by 0.5 parts per million, reduced the bicarbonate concentration by 47%, and raised the pH by 2. Considering a 0.1 pH increase in the ocean is equivalent to extracting all the dissolved carbon dioxide since the Industrial Revolution, the 2 pH increase would be imperative.
Stage 2 was engineering the Chaeto Biofilters. Chaeto Biofilters are made from high-density polyethylene, an environmentally safe plastic that doesn't leach chemicals, durable to prevent microplastics, and heat-resistant. The device features filtration holes, recycled bottles, an anchor, and a GPS tracker. The 4-gallon prototype will be scaled to 2,000-gallon biofilters, costing $9,600 with the wholesale price of $70,300.
Throughout the invention process, we experienced the challenges of caring for the algae, which we spoke to aquarium hobbyists about. To evaluate our invention, we implemented Chaeto Biofilters in local lagoons in the San Francisco Bay.
After, we tweaked our invention to improve its practicality. Significant additions included a tracking mode GPS tracker for maintenance purposes. Furthermore, we made the filtration hole smaller to prevent the Chaetomorpha from escaping and becoming an invasive species.
Our invention remains remarkably unique. Although Although algae genetic engineering has been applied to biofuels and filtration, scientists have never modified algae to mitigate ocean acidification. You may be wondering, what makes our invention distinctive?
Well, by naturally modifying enzymes in Chaetomorpha, the invention eliminates the need for expensive technology and can be reproduced in the developing world. Chaetomorpha can thrive in nutrient-poor regions, making the technology resilient. The simplistic design of the Chaeto biofilters could be mass-produced and universally adjusted to accommodate environments.
Our team will sell Chaeto biofilters through two means. First, the pursuit of government contracts, and second, commercially selling to environmental agencies. Nations including the United States, United Kingdom, and Australia have each pledged upwards of $10 billion to marine conservation.
As a timeline, in 2022, our team will invest into a warehouse and pilot the technology. In 2023, the product will be available for orders, and by 2025, we anticipate the approval of our patent and the completion of the facility.
Finally, the invention was reviewed by 6 scientists and 8 industry experts. On average, our scientific report scored a 9.5 and our business plan scored a 9.4.
Thank you.